regarding polyethylene. It is basically long chain polymer made of monomer ethylene C2H4 joined by covalent bond. Manufacturing consists of 5 steps: polymerization, shaping, sterilization, heating, and packing. Polymerization. It can be additional polymerization or condensation polymerization. Additional polymerization makes a high density polymer and very brittle. Condensation polymerization, two ethylene comes together, lose water. The process is called Ziegler effect. Ethylene gas is basically polymerized at low temperature and low pressure to form a powder. This powder is now going on for shaping. Shaping can be done by ram bar extrusion, sheet compression molding, or direct compression molding. Direct compression molding is the best. The first two can cause chain scission, while chain break release free radical, making potentially even more brittle. Machining also use addition of calcium stearate to prevent caking and stain polymers yellow and brittle. So direct polymer compression molding is the best. Third step is sterilization. It can be done in ethylene oxide. Disadvantages as no formation of cross-linking, can be done in heat which will melt, and sterilize in gamma radiation is the best. Sterilization in gamma radiation gives cross-linking and also cause free radical formation. Therefore, it's best to have sterilization in inert environment, which causes more cross-linking and improve resistance to wear. If oxygen is there, it will create radicals and make it brittle and cause catastrophic wear. So sterilization in inert environment with gamma radiation is done, which causes more cross-linking and improve resistance to wear. Regarding the forms, it has crystalline form and amorphous form. Crystalline form is organized and has no cross-linking. Amorphous is random but has cross-linking. Normally crystallinity is about 45 to 65%. The more you do the cross-linking, it becomes brittle. The more crystalline, it causes less cross-linking and make it tough but less wear properties. Then comes heating. This is treated to reduce the amount of free radicals. There are two options. Out of them, annealing is done. Either you can do annealing or melting. In annealing, not all free radicals are removed, but they maintain the mechanical property. Newer generation, they also add vitamin E as antioxidant as free radical scavenger. Then packing is done in vacuum. It is in date, expiry is written, and it's done in oxygen depleted environment. Regarding the forms, there is ultra high molecular polyethylene, in which the radiation is 75 kilogray, and highly cross-linked polyethylene, which is 100 kilogray. So there is more cross-linking in highly cross-linked polyethylene. It does give the implant better wear properties, but it also makes it more brittle. While the ultra high molecular polyethylene is less brittle. Highly cross-link is used in the hips, and the ultra high polyethylene is used in the knee because the knee is functioning at an SN curve higher than the threshold, and hip is working below the threshold of endurance limit. Properties: it's ductile, cheap, wear resistance, close young modulus to the bone, so less modulus mismatch. Used as a bearing surface in arthroplasty.